just because it's so much fun, and it's something I've just always enjoyed doing. It's a creative endeavor. It has just lots to offer, and of course it's extremely important. I mean, mathematics is vital to solving the problems of today, and so I really like understanding things, and I enjoy trying to explain them to others, which is what I've done, as a math writer. It's what I did as a math teacher. I had classrooms of students I was trying to, explain math to. And as a writer, I've had a readership that I've tried to explain math to. Difference being that I could give exams, I could see how well I had done with my students. With my readers, I only know if I get letters or corrections. It's hard to say for sure without just making stuff up, but I certainly was always interested in math and good enough at it in school. I remember when I was in 4th grade, the teacher did pull aside a few of us for some extra math activities and gave us little math problems. The one that I really remember was it's a classic problem of putting 9 dots in a 3x3 grid, and you're supposed to connect them with 4 straight lines without raising the pencil. And it was something that I couldn't figure out how to do. And I thought about it for I don't know how long. It was probably several days before we got back together and the teacher showed us the solution, which I'm not going to describe except beyond the fact that it involves thinking outside the box. And that kind of really opened my eyes to, just the possibilities of creative thought, and just, how much fun it is to think about math even if you can't get the answer. Just spending the time, and then when you either do get the answer yourself, or on occasion when you're shown how to do it, and it contains such a remarkable, new insight. Probably that, as much as anything, set me on a course for what I do. And then I just continued to take math and enjoy it. I had good teachers, many good teachers along the way. So I just wound up majoring in math and then going on to graduate school. Okay, discovering at some point you actually had to really work at it. And even that could be fun when it wasn't totally frustrating. I did a PhD in mathematics, started out on a standard academic trajectory, okay, and when it was going in the usual trajectory style, at some point I did a series of postdocs in the US. So after getting my PhD, I went to MIT, Massachusetts Institute of Technology for a couple of years. Then was at the Ohio State University, as I like to say, and then at St. Olaf College in Minnesota. And at that point, I was looking at other academic positions and thinking about other things I might do, but the opportunity came along to take a crack at freelance mathematics writing, which is something, writing and it was something I've always had an interest in, and it kind of worked out well. It was kind of a classic case of being the right person, certainly at the right place and definitely at the right time. I was at St. Olaf College, and one of the people in the math department, a man named Lynn Steen, was well connected in not only the math community but the science community in general. And as it happened, there was a staff writer for Science magazine who had been doing their math reporting for the last 10 or 15 years, And she left Science magazine for the New York Times, where she still writes, mainly doing biomedical reporting, but she did math reporting from time to time for Science. They were left without anyone on staff who regularly wrote about math, but this Professor Steen knew the editor of Science magazine, chatted with him about their loss of Gina Collada, their staff writer, and the editor there said, yes, we really need someone who could do some math reporting. And Lynn Steen said, well, I know a guy. So I was very, very lucky as a science journalist my first assignment came about by having the editor of one of the premier publications in the world call me up and ask me if I would please write something for them. And I said, well, let me think about that. Yes. A lot of credit really belongs with Lynn Steen. He had identified me as somebody who could write, and he had me do some writing projects for him for some math grants that he had. So he wasn't just pushing me off on these people. He actually had some confidence I could do this. And I also, at the same time, already had a relationship with the publisher, Klaus Peters, who published my book, Mistakes, which I had written initially as a grad student and then finished it when I was at MIT. And Klaus Peters and his wife Alice, who had their own publishing company for many years, were encouraging me to continue writing. So I had a number of really helpful people who helped me along the way. I've always known I was extremely lucky. It wasn't until I started, as a regular writer and meeting other science writers to realize just exactly how fortunate I was to get the start I did. There are things that, I understand kind of naturally, either because of my mathematical background. So, for example, Fermat's last theorem was finally proved in 1993 to 94. The Fermat's last theorem was basically, the proof was a bridge between two areas of mathematics, elliptic curves on the one hand and modular forms on the other. My dissertation was done on the modular form side, so I like to think I am one pebble in the bridge that Andrew Wiles constructed to complete the proof of Fermat's last theorem. So when that story came up, it was kind of easy for me. The research part of the reporting was already done for me years earlier. The hard part there was to figure out how to describe things like elliptic curves and modular forms and stuff like that in terms that non-mathematicians can relate to. Of course, Fermat's last theorem starts with a very simple equation that people are generally able to at least look at and get a sense for. Other things I have enjoyed writing about are things that have some sort of connection with art. If you can get a picture in your article, okay. There's this saying, a picture is worth 1,000 words. I once figured out a page of Science magazine would fit about 1,000 words. If I could get a picture on about a quarter of the page, that picture would be worth 250 words. Okay. So a lot of the articles I've done over the years, whenever there's some nice artwork, I enjoy those. And then I've enjoyed articles that have, talk about applications of mathematics and the usefulness, sometimes the unexpected simplicity of the usefulness of mathematics. One of my favorite stories was about a mathematical model algorithm for doing kidney donations, which actually later wound up winning a Nobel Prize, or it was part of the work that won a Nobel Prize in economics. It was to design a system for matching up patients who need kidneys and have a willing donor, like a relative or a friend, who would gladly give their friend or relative their kidney, but they're not a match. But when you have many patients who have willing donors who are not a match, you can sometimes find cycles where one donor can match one patient, whose donor can match another, whose donor can match another, and you get around in a cycle. And the interesting mathematical problem that had to be addressed there was to make sure that people entering this couldn't kind of game the system and misrepresent what they actually needed to get to make sure that they got a match. And the mathematics of it is very simple, very powerful, and it literally has saved lives because it's been used. They've done kidney transplants with as many as 8 different patients and donors. So it's the type of mathematics that really appeals to me because you can see it, it immediately benefits people. The first thing to recognize is that we all make mistakes, or most of us do at least, and not to really worry about them. That naturally you want to correct mistakes. You don't usually intentionally make mistakes, but mistakes are a part of life. In fact, I would say if you're not making mistakes on a regular basis, it's because you're not really doing much. And so, I've always known from a long time ago that when I'm doing mathematics in particular, and just about anything I do, but math in particular, I tend to make certain types of mistakes. I just regularly get things wrong. I usually have to do a algebraic calculation at least 3 times, and if 2 of them match, I figure those are the ones that are correct. Sometimes I have to do it 4 times to get 2 that are the same. And so actually when I was in graduate school and kind of finishing up my dissertation, I had finished my dissertation and I was teaching a second semester calculus course with integrals and things like this. And it just occurred to me that it might be useful for my students if I wrote a set of notes that explains in the course they were taking just types of mistakes that you can look for and easy ways to identify them and then hopefully correct them. And I wrote up a set of notes, and then I gave it this clever title that I don't know how it would look in Serbian, but mistakes in English is correctly spelled one way. When you spell it the way I do in the title, the stakes part there is the English word for the meat, the barbecue meat or whatnot. So it's kind of semi-recognizable. And then when I was at MIT the next year on a postdoc, this was when I met Klaus Peters. He was publishing. His publishing office was in the Cambridge, Massachusetts area, right down the street from MIT, and I just went into the office with this, essentially half of a book, because I had done it for this, not only half of a book, but the second half of a book, because I had been teaching the second semester of calculus. And so I had these notes for the second half of the course, and gave it, submitted it, and some days later got this call that he wanted to meet, and I went in and he said, this is a very nice book. He was a very kind man. There's a lot of humor in the book. That's another thing that I kind of like to stress, to just have fun with math. And if you're going to make mistakes, you might as well enjoy them. And Klaus appreciated this, but he said he did notice that it was only half of a book, and the second half of a book at that, and said he would be interested in publishing it if I would please write the first half of the book. And so I said, I will do that. Okay. So my original goal on this was to write a book. It's a very slim little thing. It's a calculus supplement, so it was intended to be something that students would purchase. Any student taking a course in calculus, in addition to the calculus textbook, would buy my little thing to go along with it. And I thought, there are a couple million students who take calculus every year, just in the US, and I don't know how many worldwide. And I thought, if they all buy that book, okay, hasn't quite worked out that way, but maybe now it will, especially if there's a good Serbian translation done. Loopy Loop was done for a creative math science writing workshop at the Banff, the Canadian Math Research Institute in Banff. Later, Loopy Love appeared as an art exhibit at Bridges, but it was done for a writing workshop, and we can show it here. Yeah. Okay. The great joy is not reading this, but just scrolling the paper. And the idea I had for this workshop, they invited me, even though I'm not really a creative writer, I'm a journalist. I'm not supposed to make stuff up, okay? But they asked me to come, and I thought it would be a good opportunity to, again, have some fun and explore something. And my initial idea, I thought, I've long had this notion in mind. I'd like to write a short story with the structure of a trefoil knot. And I thought, going to this workshop, I might be able to figure out what I meant by that. It was just something that had occurred to me a long time ago. And so I went around for a number of days trying to figure out what it would mean to write a story with a topological structure. And I couldn't figure out, nothing came to me, but then suddenly it occurred to me I could literally write a short story on a Mobius strip. And I saw immediately in my mind what it would look like, okay? And then of course I had to figure out what the story would be. I went around for a number of days before I started the story thinking, what a creative, original idea this was. And then I came down to earth and decided somebody has already done this. And in fact, this has been done a number of, a handful of times. There's a famous group called the Oulipo group, kind of came out of France, and it was a collection of French writers and mathematicians who used some combinatorial mathematics to guide the writing. And they did some of their own writing on Mobius strips. I also discovered there's a contemporary poet in the US who had written a collection of poetry, a couple of which were intended to be cut out of the book, assembled into a strip, okay, taped together and read. So, this idea, which I came up with by myself and thought how brilliant I am. Okay, of course I've discovered other people have thought of it, but I thought I'm going to go ahead and do it. Actually did not, look at what anyone else had done because I didn't want to be influenced. And then thought about what I might write about, and I decided to try to reflect properties of a Mobius strip, which, it only has one side, but when you look at it, there are two sides. So the story itself is kind of a back and forth conversation between a couple, okay? And I came up with the names Daniel and Danielle, or nicknames Danny and Danny. And so the story just kind of goes back and forth. They're talking, and like a lot of couples, after a while you start going over the same things. You have the same conversation just over and over again. And so that was the idea of just having it as a Mobius strip. It would be sort of two people who are one person kind of thing, and sometimes you weren't sure who was talking. It goes back and forth. And then I just started writing and thought, okay, at some point, and as I wrote, I was doing it on a computer and would put line breaks. And at some point I felt I should be about halfway through, and I'd better start steering the story back to where I had started. And my goal was to do so in kind of a seamless fashion so that anyone reading it would not be able to tell where I had started. And it would just seem like one story that just goes on and on and on. So when I produced it, the other thing that happened was I knew when I went to the workshop, I didn't just want to take a manuscript and show it to people and say, imagine this is on a Mobius strip. I knew I really wanted to have a physical object. As it happens, our next door neighbor runs a small literary press. So he did the print job here on fancy Fabriano paper with letterpress print and all this stuff, which when he brought it back to me, I had envisioned something kind of loose and floppy and so on, and it came with this somewhat rigid style. So, people looking at it sort of said, it looks like a sculpture. It actually has appeared in a couple of math art exhibits. The other thing that I did for the purpose of the workshop, I went and numbered the lines so that people could, you can't refer to what page are you on. They could say, right around line 130, and maybe the key thing I did, that of course the thing was printed on one long strip, and then I had to, turn it, loop it and twist it, and at the workshop I taped it with Scotch tape, but to disguise where I had actually started writing, I took my computer file and just arbitrarily cut it somewhere and moved it, a portion to the top, and then put the numbering on. So the numbering has no reference to, the origin of the story. It's just for the purpose of describing things. It also makes it sort of look like, one of these classical, Greek or Roman poems, that always gets numbered, so it adds to the aesthetic part of it. But the real surprise was just, again, I invite you to try that yourself. It takes a little practice, but the scrolling of the paper is its own feel to it and gives a different sense to how the story goes. So when I submitted this to this art exhibit, I had to write up a little statement describing it, and I sent and I didn't know what to say, so I said, it was done for a workshop, and it was done with Fabriano paper and letterpress print, and assembled, with Scotch tape, and so on. I described the construction. I sent my statement to an artist friend, who just to make sure it would, an artist, a real artist reading it wouldn't just, say how silly. The main criticism I got back from this artist was, you are not to use Scotch tape on a work of art. You are to use archival quality glue. And, so I said, yes, I will do that. So I went to an art store as instructed, got archival quality glue, and ever since I've assembled them that way.